Okay, welcome back. Here we're going to continue from where we stopped to question 15b, Roman figure 2. The question says, figure 2.1 represents a circuit, and we have to express the value of E in terms of I and R. So let's get started. Solution. So the circuit is like this. We have this resistor. We have another resistor. So we say when resistors are arranged side by side, it shows they are in parallel. So here is this. Then we have another one like this. Then from there, we have something like this. Here is there are two cells. Here is one cell connected in series with another cell. Then, so this is the whole circuit. So the first cell has the EMF to be E and the internal resistance R. This one also EMF is E and internal resistance is also R. So here the value is 3 ohms and this value is also 3 ohms, while this one is 2 ohms. Then the current flowing from these cells is I. So in order for us to tackle this question, first and foremost, you look at your circuit. So you have to find the total resistance, total internal resistance, and also total EMF of the cell. So we first of all look at the resistor. So let us name this resistor R1. Here is R2, R3. So as we can see, R1 and R2 are arranged side by side. So they are in parallel. So we have to find the equivalent resistance. So in order for us to do that, say let R1, 2 represent the total resistance of R1 and R2. So in that case, since they are in parallel, remember we have this formula: 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, depending on number of the resistors in the circuit. So that's what we're going to use here. So in that case, I'm going to have 1 over R1, 2 is equal to 1 over R1 plus 1 over R2. So I can decide to just substitute the value here. That will be 1 all over R1 is 3 plus 1 over R2 is also 3. So that would be equal to, here the LCM here is 3. So 3 and 3, 1 times this, that will give us that is 1 also plus 1 also, that will give us 2 all over 3. So here I have 1 over R1, 2 to be equal to 2 all over 3. By the time I cross multiply, that implies that R1, 2 will be equal to 3 all over 2, which will give us 1.5 ohms. 1.5 ohms. So I can redraw the circuit diagram now to be like this. Here will be the equivalent resistor that I just found, and here will be the resistance R3, and here I have this. Here is the cell. There's another cell. Then I have something like this. Okay, so here is my I. Here is my E. Another E. Here is R. Here is R. Here is R1, 2. Here is R3. Here is 2 ohms. The value is 2 ohms. The value here is now is 1.5 ohms. So I have something like this. Now R1, 2 and R3 are now in series. So for me to get the total resistance of the whole external resistors, so it's going to be R1, comma 2 plus R3. That would be 1.5 plus 2. So R total of the whole circuit will be equal to 3.5 ohms. I hope this is understood. So I have 3.5 ohms at the whole, the total in external resistance. Okay, having done that, so I have my R total. I have my R total to be 3.5 ohms. Then since the external resistance, so since the first cell has EMF of E, so E1 is equal to E, and E2 is also equal to E. And they are in series, therefore, E total is equal to E1 plus E2. So that will give us, remember E1 is E, so I'm going to have E plus E, which is equal to 2E. So the total EMF is equal to 2E. Now, total internal resistance also, R total will be equal to R1 plus R2. And from there, R1 is R, R2 is also R, so that will give us what? 2R. So R total is equal to this. So R total is equal to 2R. Therefore, remember the formula that I is equal to E all over R plus R. So I here is the I total. The E will be total total EMF all over R total plus R total internal resistance total, right? So in that case, I have I will be equal to E total is 2E all over R total is 3.5 plus internal resistance, total internal resistance is 2R. So I can now cross multiply. Remember they said I should express E in terms of I and R. So that should show that's to show I have to make E subject of the formula. So in that case, I'm going to have 2E is equal to I into bracket 3.5 plus 2R. So that by the time I divide both sides by 2, I'll have E will be equal to I into bracket 3.5 plus 2R all over 2. So that is how to express E in terms of I and R as the question demands. Thank you for watching. We continue from here in our next class.